Okay, so one student here. Please sign your attendance. Thank you. Okay, every other students, please sign your attendance here online by going to the website here, scrolling down and click on this link. Sign your attendance, and I will fill in your attendance record into the official form later. Thank you. Please sign your attendance now. And when you are ready, please say okay in the chat room, and then I will get started. Thank you. Okay, good morning, ladies and gentlemen. Welcome to SPSS and Data Analysis in Practice. I am Dr. Zhang. You can find my name here by scrolling down to the bottom of the website. And this is my email at BDC. So if you have any questions after class, you can just send me an email and I will reply you as soon as possible. Now, before I get started, I wish to ask you one question. Okay, for students from online, please put your answer into the chat room. So how well do you think you know about SPSS? Please let me know in the chat room. How well do you think you know about SPSS? Anyone? No? Okay, now maybe I put it this way. So this course is about SPSS, which is a software for statistical analysis. So I know all of you here are doing your final year project, and next semester you are going to have your data, and you are going to analyze your data in SPSS or in some other computer software. But one very important thing to know about SPSS is that it is just a software for data analysis. And SPSS, the software alone, cannot solve all your problems that you encounter in your research. And the reason is that research is a really difficult thing to do. And to do research, of course, you need to know about the software because the software helps you do the statistics. But the software alone is not enough. You also need to know about statistics. I mean, the concepts of statistics. The reason is that when you work on SPSS, it is really easy for you to choose some of the statistical methods to run on your data. You simply go to certain menu, click on it, and then you get the result in a few seconds. That is the easy part. But the difficult part is that you need to find or you need to design which method you want to use. There are so many methods in the menu, and you need to choose the correct method. And if you don't choose the correct method, then no matter what you get from the software, the result will not be very helpful, or the result may even be misleading if you choose the wrong method. So in this sense, statistics is a very important skill before you learn to use SPSS. Now, another skill that is also involved in the data analysis is research method. So research method, I mean not only the statistics, but something at a higher level. For example, you need to pick the correct method to do your research. Now, And for this reason, this course has been quite a difficult one because you are not only learning about the software, you are also going to learn about statistics. And in addition to that, and more importantly, you need to learn about research method. So that's why I say here in the course title, I put in SPSS, but also data analysis. And I want to make everything as practical as possible. So that's why I put the in practice here. Okay, a second student face-to-face here. So now to warm up a little bit, let's go do something together before we go into the lecture. So now everyone, please click on the introduction link here in the website. Okay, so this is lesson 1, and altogether we have 3 lessons in this course. And in today's lesson, I'm going to talk about some of the basic concepts of statistics. And also I want to talk about data preparation, which is something very important. Data preparation basically means that you need to prepare your data. You need to clean your data in a sense that you need to remove the problematic data, fix other problems in your data set before you really get started with the data analysis. So that is a very important thing to do. And I will give you a demonstration today to show you how this can be done in SPSS. But before that, I want to ask you a few questions. So everyone, I want to do a Kahoot session. I don't know if you have used this before or not, but please go to a web browser, go to this website, and then you will be asked to enter a PIN number. So please enter this PIN number as shown on the screen, and then give me your nickname, and I will ask you a few questions. Okay, everyone, please go to this website, enter the game PIN, and give me your name. And I will see your name here. Okay. The first one. Let me see how many students we have. Wow. Okay, around 13 here online. And 2 students here face-to-face. So around, I'm expecting around 15 students, more around this number. Ten, 5 more. Twelve. 上面呢個，上面呢個。Okay, 12 of you. Any more? Yeah. 13. 你嚟㗎嘛 ？Okay. Any more? No? If no, then I will start the questions. Okay, now, okay, okay, 12. Yeah, 冇咗一個。Okay. Okay, any more? So maybe I will get started. So first of all, I just want to ask you a few questions, a few very simple questions. So what you need to do is that you will find the question on the screen and also 4 colors which represent the 4 options. And then on your screen, you get the 4 colors. So just click on the color that corresponds to the answer that you want to choose. Okay, so the first question is, how well do you know about SPSS? Just a simple statistics. Okay, so 8 of you say that you are just absolute beginner, and 2 of you say that you already got some experience, but not much, and no students think that they are regular user or a boss level user. Oh, okay, that's good, by the way, because in this course, I am going to assume that you know absolutely nothing about SPSS. So don't worry about that. I will start from the very beginning. Now, the second question. So the second question, how well do you know about statistics? Just your self-evaluation. How well do you know about statistics? Okay, so 11 of you say that you can do some simple statistics. 1 of you say that you know absolutely nothing about statistics. Okay, but wow, 1 of you say that you are a data scientist or statistician. Oh, that's very good. So if I have some problem or question about statistics, then I will ask you. And please give me teach me how to do the data scientist thing. So, okay, now the next one. In the next question, I want to ask you something to test your knowledge in statistics. Since most of you say that you already know something about statistics. Okay, we have 5 numbers. So what is the mean of these 5 numbers? Okay, please do not use a calculator. The mean is just the average, 平均值, average. Okay, so most of you got the answer correct. Now, in fact, if you have 5 numbers like this, they are equal distance from each other, then the mean must be the number in the middle. So you don't really need to do any calculation. But in case you want to do some calculation to train your mind, you can just do it in this way. You can add 1 to the 9, which gives you a 10. You can add 3 to the 7, which also gives you a 10, so that is 20. Add the 5 here in the middle, it gives you 25, and divided by 5, that gives you 5. Okay, so that is the mean of the number. Okay, the next one. Now, what is the median of the 4 numbers? Median in Chinese, it is 中位數, so it means the number in the middle. So what is the median? Okay, very good. So the number in the middle means, really, it means the number in the middle, but there is no single number in the middle in this data set because we have 4 numbers, and we have the numbers 4 and 6 in the middle. So the number between these 2 numbers, we take the average of these 2 numbers. So that means the average of 4 and 6. and that gives you a 5. So the 5 here is the median. Now, I don't really worry that you don't understand the mean or the median. So these are just simple statistics. And that is not the point of asking you the questions here. The point is that now in the SPSS, you don't really need to worry about the calculation. You want to find the mean and the median, then you simply go to some menu, click on some options, and then it will give you all this immediately. So calculation is not the key here. What is important here is that you should understand the meaning of doing this. So for example, it is easy to calculate the mean of some numbers, but it is not always meaningful to calculate the mean of the numbers like this, because there are some conditions in which should be satisfied in order to make the mean value really meaningful. So what I am going to teach you in this short course is one of the things is that I want to teach you in what situation should you use the mean, and in what other situation should you not use the mean, but rather use the median or some other statistics. That is the important thing you want to learn. Calculation alone is not the most important thing. Okay, now enough for the warm-up. Now, please do not close the browser tab because we are going to use it again. So just put it aside. And we are going to come back to here later after I finish the lecture. So in our website here, in the introduction, please scroll down to activity 1.1. I am going to go through a short lecture for you in our first hour. And then after that, I will do some demonstration on SPSS. So go to introduction here. Okay, in case you don't know the URL of this website, now this is the URL. You can scan the QR code, or you can just type this URL. Okay, I mean for students here face to face. Okay, just try to write down the URL because we are going to come back to this again and again in the following weeks. Okay, and for students from online, please go to introduction here. So everyone, please go to activity 1.1, and here I have a link to the lecture notes. So you can download and open this document, the lecture notes. Okay, so I want to tell you through the lecture some of the basic concepts of statistics. Now, but before that, I need to tell you another thing, which is also very important. Now, as I mentioned a few minutes ago, statistics, of course, is very difficult. But what is more difficult and even also more important is the research method. So before you decide to use the questionnaire to collect some data and analyze your data using statistics, you need to think about why you want to do the questionnaire survey. Okay, that is one very important thing. Now, if you have learned some research method, or you might have heard that there are basically two types of research. The first type on the left-hand side is the qualitative type. Okay, in Chinese, this is the 质性研究, qualitative. And on the right-hand side, we have the quantitative. In Chinese, we call it 量化研究. So basically, when we do statistics, we are doing quantitative study. And quantitative study is characterized by the use of questionnaire survey to collect some data from your respondents, and then you analyze the data using the computer software. But the qualitative study usually is characterized by doing interviews. So there is no questionnaire in that case. You simply go to some person and ask him or her some questions. Okay, you talk to that person for like a half an hour or longer to ask him or her a long list of questions. Okay, so that is interview. Now, one very important thing to think about is why should you do questionnaire survey sometimes, and why should you do interview sometimes? Now, I want to give you one example. Okay, we have 3 students here, so it's good for me to do some demonstration. Okay, so suppose that you want to conduct a research, you want to ask people, which restaurant do you like more? So I give you 2 options, McDonald's and KFC. Okay, so McDonald's or KFC, which one do you like more?
In terms of food, I love KFC, and in terms of convenience, I love McDonald's.
Okay, so he already gave a very complicated answer. In terms of the food, he loves KFC, but in terms of convenience, he loves McDonald's. Okay, so but suppose that I am just giving you a questionnaire. Okay, you can choose only one from the 2 options. So which one would you choose? KFC. Okay, so which one would you choose? McDonald's. Which one? KFC. Okay, so we have 3 students here, and 2 of them choose KFC. 1 of them choose McDonald's. So so this is my research data, and then I can conclude that 2/3 or around 66.67% of everyone. Okay, everyone. Okay, notice the word I use. Everyone prefer KFC more than McDonald's. Okay, this is one type of question that you can ask using the questionnaire. But when I ask this question, think about the requirements. Okay, when I ask this question, I need to provide the options. So it means that I need to think about the options before I distribute the questionnaire. If I don't know what restaurants there are, then I cannot write down the options, right? So one requirement of using or doing the questionnaire survey is that you need to think about the options first, and then you need to write down the possible answers for them to choose. If you don't even know what kind of restaurants there are, then it's not possible for you to write down a simple questionnaire like that. Okay, so this is one thing I want you to remember. Okay, but as you see from the data that I collect from here, one student say that, okay, in terms of the food, I like the KFC, but in terms of the convenience, I like McDonald's. Now, this is something that cannot be covered by the question that I just showed you, right? Because the question asks you just to write down, choose one from the 2, okay? So how do you fix this problem using the questionnaire? You can ask the question in a slightly different way, or I can add one more question. So maybe I say, okay, of course, the first question also asks you which restaurant you like more. And then in the second question, I ask you, why? Why did you choose the option in the first question? Okay, and then you may say, okay. And then when I ask this question, one way to do it is to, I put down the options as well. So, and then I think about, okay, what are the possible reasons why people choose this one? So I put down, okay, option 1, the food is delicious. Option 2, it is convenient. Option 3, the price is cheap. Option 4, I like the kids meal, and so forth. Now, to do that, again, you need to write down all the possible options. And this time, the possible options are more difficult to write down because there can be a lot of possible reasons. So in this way, you think, well, the questionnaire, you find a little bit difficult to do this using a questionnaire, but you can still do this. Like if you really don't know what the possible options are, then you can put down some open-end questions like others, and then please specify. So in this way, you still can ask people to write down their reason. But this kind of reason is a simple reason, right? So if the answer is expected to be simple, then that's fine. Okay, you like the food. Okay, so you choose KFC. But what if you want to know more? Like, why do you like the food at KFC? Or why do you choose McDonald's? Because it is convenient. Why do you think that KFC is less convenient, and so forth? Or some other people may also say, well, I am indifferent between these two. I don't have any special preference. Okay, then you have to take care of this special situation as well. So what we see is that the more you want to know, or the deeper you want to know, the more difficult it is for you to use the questionnaire to get your answer. And if you like, you want to ask, okay, can you share with me your experience with these restaurants? Okay, that could be a long story to tell, right? And the questionnaire now, it certainly does not seem to be a very good choice to do that. So instead of a questionnaire, you may want to do it in another way. Like you conduct an interview with that person. You ask them, first of all, you may ask them some simple questions like which restaurant you like, and why, and what is your experience, and so forth. Now, in this way, you cannot really predict what your respondent is going to tell you, because there might be a lot of different stories. Everyone may tell you a different story. And even the questions you ask are not predictable, because, for example, if you say, okay, you like the kids meal, then I may ask you, okay, do you have kids, or you yourself like the toys, and so forth. But if someone else talk about another reason, then you are not going to ask her about the kids meal, right? So depending on what you tell, I am going to ask different questions. So it means that in this case, it is really not very possible to write down all the questions and all the options into the questionnaire. And in this case, the interview might be a better choice. So from these questions, there is really some important difference between quantitative study and qualitative study. It really depends on your research questions or research objectives. So if you are going to know something very specific, if you already have idea about what you want to ask, and you even know the possible options or possible answers, then quantitative study is the good way. Okay, the one on the right hand side. But suppose that you don't really know a lot about that question, or you want to know very deep about how a certain person is thinking about this question, then the questionnaire is not a good choice. You want to do an interview. That is the qualitative study, which is on the left-hand side. Now, in general, we say that the qualitative study is more of an exploratory nature. So that means that you do not really know what you want to find. You just want to explore the problem a little bit. So that is exploratory. Quantitative is more confirmatory. Confirmatory means that you already know that something might be true. You have a very well-defined question to ask, but you just want to use the data to prove or to disprove your hypothesis. So that is quantitative study. So it really depends on what you try to do. So the qualitative study way is good for understanding, because you can ask very deep questions and ask a lot of follow-up questions. But that is not good for generalization, because like if you ask different people different questions and they tell you different stories, then how can you generalize their answers to other people? But if I just ask a simple question like which restaurant you like more, and then I find, okay, 66.67% of everyone like KFC more. Of course, I have only a sample size, a very small sample size here. But in principle, you can do the same to a larger sample size. Suppose I ask 500 people. I ask this question, then I can easily generalize the percentage to the rest of the population. So quantitative is good for generalization. But on the other hand, it is not good for understanding, because I can only ask very shallow questions, simple questions. And there is no way for me to ask a lot of follow-up questions using the survey, because I cannot write down the follow-up questions in advance. So the quantitative It's good for generalization, but it does not really tell you a lot about what people think. Okay, so notice this difference. Now, sampling. Quantitative method, we usually use random sampling because we want to generalize the findings. So we want the sample to be good representative of the population. I will come back to here again in a few minutes. But qualitative study, pay attention to this. Qualitative study, now many people think that, well, we do random sampling all the time, but in fact, it is not true. Now, the reason is that, now suppose that you want to ask people something, you want to ask some deep questions to other people. Like you want to know how to become a rich person. So of course, when you want to do an interview, you ask Ma Wen or Jack Ma, but do not ask me, right? You choose someone that you think will give you the answer, right? So in qualitative study, we pick the specific people to attend your interview, to invite them to attend your interview. We don't just pick any random person on the street, because they might not be able to give you the deep answer that you are looking for. So that is why we want to do non-random sampling in qualitative studies. So this is a very important point to keep in mind. Now, sample size. Because we want to generalize the quantitative finding, we want the sample size to be as large as possible. But for the qualitative study, the sample size is usually small, and there are two reasons to that. First, we aim for understanding and not for generalization. So we don't really need a large sample size. And second, for interview, it is not really practical to do a large sample size because you spend a lot of time interviewing one person. For questionnaire, it is easy. You just distribute the questionnaire to a large number of people, and then they will fill in and give you the data. But for the interview, you need to really spend time to talk to them one by one. For interview, usually for academic research, each interview might usually last for at least 30 minutes. And so let's say if you want to interview 100 people, well, that is a very long period of time. Okay, so that is not an easy thing to do. So that's why the qualitative sample size is usually small. Okay, data collection methods. Interview is what we do in qualitative study. And sometimes you can also do observation. Observation means that you do not really do any interview with people, but maybe you just sit down at the restaurant and observe other people and see what they do and write down your notes and try to analyze your notes afterwards to see what you get, what you see. Okay, so that is observation. Quantitative study, we usually do questionnaire. And finally, for the method of data analysis, for qualitative study, you can do something like thematic analysis, or we also call this QDA, which simply stands for qualitative data analysis, which is a very dumb name to use, I think. But anyway, they call it QDA. And for quantitative study, we use statistics. So before we move on to the statistics in the following 3 weeks, I want you to remind yourself why you are doing quantitative study or why you are doing statistics. Now, in case some of you may want to use qualitative study instead, so you can also go to this website in item number 5 here, because previously another class requested me to deliver a talk on qualitative data analysis. So if you need that, you can also go to here and download the corresponding materials. But for now, in these 3 weeks, we are going to focus on the quantitative methods. Okay. Now, let's talk about statistics. Statistics in Chinese, it means 統計. Okay, but for those who know Chinese, I want you to think about the meaning of these two words in Chinese. What is 統 and what is 計? Any idea from online? In Chinese, okay, 字面上 what is 統 and what is 計 ？OK， 都係問翻現場嘅，佢有4個人咯。OK， 咩叫統？啊，咩叫統？統籌 OK，so 統 means 統籌 organize。So one way to understand it, yeah, 統 is 統籌, but that is not the okay. 統籌 means you put everything together and try to plan things. Okay, and we also meet general counting. General counting. I get an answer from online. General counting. Now, 統 actually means you put something together. 統一. Okay, so you put something together. Why do you put something together? Because you want to do some calculation on them. And calculation is 計, obviously. So 統計 means that you put something together and want to do some calculation on them. But you may ask, why do I want to put something together and do some calculation on them? And here we have the English definition. 統 means you collect data. So you collect data from others. You put the data together, that is 統. And after that, you want to do the calculation. But why you do the calculation? You do the calculation because you want to summarize the data. Summarize is a very important keyword. You get the data, that is a lot of data. But what is the meaning behind the data? And what do the data tell you about the research question that you are going to answer? So the way to do it is you try to summarize something important from your data, and then you draw conclusion from the data. The conclusion, of course, will serve to answer your research questions or will fulfill your research objective. Now, it means that, or it implies that in data analysis or in statistics, we don't just do any calculation casually. We do it for a reason, right? So that's why in the beginning, when I asked you about the meaning of the mean and the median, of course, everyone knows how to calculate the mean and the median, but that is not the key point here. The key point here is that when you do it, you know why you are doing it. And the why here, of course, here should be something related to your research objectives or research question. Now, if the research objectives require you to find a mean, then you find a mean. If the research objective does not require you to find a mean, then you do something else. Okay, there is always a reason for you to do something. Okay, so that is the meaning of 統計 that I want to keep in mind here. Collect, summarize, and draw conclusions. And we do that for a reason. And that reason is related to your research objectives. Okay, now let's look at this example. Okay, how many ducks are there in total? In total, 20, yeah. So we have 20 ducks. How many of the ducks wear a red hat? 5. Okay, good. So thank you. So you look at all the ducks, you count how many ducks wear a red hat. So I can conclude that, okay, out of the 20 ducks, 5 of them wear a red hat. So that is actually 25%. Now, but the ducks here is what we call the population. So this is all the ducks that we want to study. So all the ducks, 20 ducks in total. So we collect the data from all the population. But the fact is that sometimes it is really difficult to collect data from every individual in the population. But 20 is not a large number. But suppose that I tell you, okay, we have 20 billion ducks. And I ask you how many of them are wearing a red hat. How can you ask, okay, how can you look at all the 20 billion ducks and count how many of them are wearing a red hat? Of course, that is not a very practical thing to do, right? So what we need to do here is to be lazy. So instead of looking at the whole population, we only pick some of them to look at. And we do that by random. As I said, in quantitative study, we collect all the data by random. So we have 5 ducks here by random. But the problem, one problem doing this is when I pick the 5 ducks and I count how many of them wear a red hat, in this case it is 1, and 1 divided by 5 gives you 20%. Now, when I draw this conclusion, I am ignoring all the ducks that are not selected. So no matter whether this duck or this duck, whether they are wearing a red hat or not, it doesn't affect my result because they are ignored. So it turns out that when you draw some sample from a population, when you draw something from a population and you always ignore something else, and when you ignore something else, you always introduce error, right? Anything not in your sample will not be considered in your statistics, and you are losing a lot of information in this sense. You don't know anything about the other 15 ducks, right? That is a problem, but that is a problem that we have to face in statistics because obviously it is not practical to look at all the ducks, right? So this is a problem that we have to face. And in our third lesson here, I will tell you how to deal with this problem. Okay, but for now, let's just focus on the sampling. Okay, so by collecting the data, we can try to summarize the data in this way. If you look at all the ducks in the population, this is called the population, everyone. There are 20 ducks in the population, and we find that 5 of them wear a red hat. And so the proportion is that it's 1 divided by 4, or 25%. 25% of the ducks wear a red hat, according to the data from the population. But if we only look at the sample, then the sample, we have the sample size of 5. Only 1 of them wear a red hat, and the proportion is 1/5, that is 20%. Okay, which answer is correct? Both of them, why? Because on the left-hand side, we are talking about the population proportion. On the right-hand side, we are talking about the sample proportion. So of course, both of them are correct, but in different contexts or in different conditions, right? But suppose that what we are really interested is the population, because no one will be interested in your sample. We always want to know about something big in statistics. Remember that we want to generalize our findings. So obviously, what we want is the answer on the left-hand side, the population. But in reality, we can only get the answer on the right-hand side. So how can we deal with that? Basically, we try to do something like this. So using the data gathered from a group to describe or draw conclusions about the same group only. The keyword is the same group. So let's say I say, okay, 1/5 of the duck in the sample wear a red hat. This conclusion is about the sample. So of course, this conclusion is correct. Now, but this is not what we are most interested in. What we are more interested in is to generalize our finding from the sample to the population, like using the data gathered from a group to infer. Infer means you make a guess. Conclusions about the population. So using the sample data, we try to infer about the population. So for example, because 1/5 of the ducks in the sample wear a red hat, we conclude that approximately 1/5 of the ducks in the population should be wearing a red hat. So we get the sample data and we use this one to make a guess about the population. But of course, all of you know that the correct answer is actually 1/4, not 1/5. But that is the best thing we can do because we do not know the population. So this is statistics. Now, the one on the left-hand side, we get data from the sample and we draw conclusion about the sample only. This is called descriptive statistics because we are just describing what we have at hand. There is no error or no inference involved in this process. We get the data from the sample and we talk about the sample, just a plain description of what we have. So we call this descriptive statistics. But what we are more interested in is the inferential statistics. Infer means you make a guess. Inferential statistics because we are using the sample data to infer about the population data. And inferential statistics is far more difficult than descriptive statistics, but it is also far more useful than descriptive statistics. Now, you may have heard about the terms like the t-test or ANOVA, all those kind of things. Actually, why you are doing that? Because you are doing inferential statistics. So inferential statistics will be the topic of our final lesson, and descriptive statistics will be the topic of the next lesson. But today, I just want to tell you the concept of these two. Okay, now let's talk more about the sampling. Now, I emphasize that random sampling is important. And by random sampling, it means that every unit of the population has the same probability of being included. Now, this is a very mathematical definition, but in order to help you understand this, I want to give you another example to show you what is not random sampling. Okay, so suppose that here. So your target population is all the university students here in this institute, only your program, but also other students from other programs, like those studying accounting, those studying hotel management, and so forth, everyone. Okay, now, suppose that you have an online questionnaire. So online questionnaire, of course, you have a link to your questionnaire. So you put the link on your Facebook, or you share the link on WhatsApp and ask your friends to pass the link over to other people who are also studying in this institution. So you ask them to do that. Okay, is it random sampling in this case? Why not? Who might not get the link?
The one who have no friends.
Yes. So it means that they were, okay, so if you pass the link to your friends, so suppose that, okay, she's your friend, you pass the link to her, and she passed the link to her friends and other friends in this institution, oh, that's fine. But suppose that there is some person sitting far outside or far in the next room, okay, who does not know your friend and who does not know your friend's friend? Then those people, although they are still students in this institution, they are still inside your population, there is certainly a very small chance for them to get the link because they don't really know you. So in that case, it is not really random sampling because some students have a much smaller probability of being included. Or in other words, we say some students have a much higher probability of being included if they are your friend or they are your friend's friend. Okay, so this is obviously not a random sampling. Okay, so the next question is, do you think this is the problem? Why? Okay, yeah, I get your point, but I would say, now, it depends. Why it depends? It depends on what question you are asking. Now, let's say I'm asking you something about like hospitality or F&B, for example. So you are an expert here. Okay, so of course your answer about this topic will be a little bit different from those people who are studying something else. Like I am teaching in another class of students from surveying. Okay, that is completely different from what you are studying. And so for the same question here, they may be giving very different answers to the questions. So in that case, if you distribute the link to your friends, it is assumed that it is your friend might be many of them are studying the same program as you with a similar background. Okay, so in that case, there will be a bias. Now, but suppose that I ask you, okay, do you like apple or orange more? So this kind of question does not seem to depend on what program you are studying, right? Or I say, okay, do you use Apple smartphone or Android smartphone, right? So in this case, although the sample is not random, the impact is not that large to this kind of question. But for other kind of questions, the impact could be very large. You can have a very large bias. So theoretically, we always want to do random sampling, but you know, in practice, it is sometimes not very practical to do it. Now, in that case, when you are writing your report, you need to write down, okay, what would be the impact or the limitation of your sampling method. If it is not really random, then you explain why you think it might not be random, but why you need to do it in this way anyway. Because sometimes you might not have other better ways to do. And at the same time, you also need to estimate the impact of this sampling method to your data. That is some kind of limitation that you need to write down in your report. Okay, so this is random sampling. Now, so how do you do really random sampling? Usually, when people try to make some random cold calls using the telephone number, the telephone book, and try to pick someone to answer their questions. Now, the telephone numbers are relatively more random in this way, but it can still be biased. Like for example, if you just only look at the phone book of all the landline, it means it's not a mobile phone number. Okay, so you make a call to someone at their home. Okay, ask them some questions. So depending on what you ask, this might introduce a bias. 點解呢? Do you know why? Yeah, some people now you think, okay, suppose that I am working outside all the day. I'm not even at home and I don't have a landline at home. How can you find me to fill in the questionnaire? Who might be staying at home all day and answering the landline? Maybe something who is working from home, or someone who might not be working at all. So depending on what you are asking, if you are asking something like related to like a professional knowledge, or something related to income and so forth, or your other characteristics, okay, that might be affected by the way you do the sampling. So in this way, that is not very random, but relatively speaking, it is better than passing your link on Facebook or WhatsApp to your friends. Okay, so randomness is a matter of you have different extent of randomness, and where the effect depends, the effect of or the impact of your sampling method depends on what kind of questions you are trying to ask. So think about this very carefully before you collect your data. Okay, are you writing your research proposal at the moment? Yeah, think about this very carefully, because if you do it wrong, there is no way for you to go back, right? Unless you redo everything from scratch. Okay, very important thing to consider. Okay, so non-random sampling means some people in the population have do not have the same probability of being included in the sample. Now, I also want to spend some time to talk about the 4 different types of random sampling techniques. So the one on the left-hand side, this one, upper left-hand corner, this one is the simple random sampling. Simple random is really simple. You have a group of people in the population and you randomly pick your points along this line. This is simple random. Now on the right-hand side here, you have stratified random. Now please look at this diagram. Can you tell me the meaning of the stratified random sampling based on what you see in the diagram here? Any ideas from online? You divide the population.
Randomly choose.
From each group, right? So basically stratified random sampling means that you divide the whole population into different groups. And from each group, you do your random sampling. Now, my next question is, why do we want to do that? What might be the advantage of doing that? Why don't just do the simple random?
Increase the chance of errors and bias.
In what sense? Why can this reduce the bias? Yeah, you get the point, but why? Now, anyone from any idea from online or 中文都 okay? Any idea? Now, first of all, let me tell you what it means by stratified random. So, instead of just picking any point randomly from this line, from this population, we divide the population into different groups, and then we do random sampling from each of the group. Okay, I get one answer. I want to get the desired result, but how? Can you elaborate? Okay, give you a like here. Now consider the following. Suppose that I am trying to study the students in this university, but there are 4 different years, like year 1, year 2, year 3, year 4. Suppose that for some reason, the population size in one of the years is much smaller than the other years. Like there are only very few year 1 students, but many year 2 students and year 3 and 4 students. So if I just pick everyone by random, because there are only very few year 1 students, it is very difficult for me to pick anyone by random who is from year 1, right? The number is small. So now if the population is really small for year 1, like maybe they only 5% of the total population, and if I want to pick anyone from year 1, then the chance is 5%. That is very small. So in this way, what you get might not, the data that you get might not represent the comments from year 1 students, because you don't have many of them from there. So one way to fix the problem is to divide everyone. Okay, I got a further answer. No, some specific group may give some specific answer. Oh yes, that is also the reason why I want to pick year 1, because I think that their answer might be different from the other groups, and I want to ensure that I have enough data from the year 1 students. If the group size is similar among the different years, then the random sampling, simple random might do it very well. But if I just want to ensure that we have similar number of individuals taken from each of the groups, then we can divide them into different groups and draw my sample from each of the groups. to ensure that I have data from every one of them. That is the stratified random. So that is actually a way to reduce bias. Okay. Okay, the third one. Systematic. This one looks a little bit different from the stratified random. Do you know what it means? Based on the diagram. It looks similar, but actually there is some crucial difference. The difference is that the point that you pick. Now for the stratified random, the red dot could be anywhere inside each group. But the systematic sampling, the red dot is at the same position, right, in each group. So what does it mean? More specific. No.
For example, you only choose boys with the ball head.
Okay. Okay, now let me put it this way. Now suppose that I am doing, okay, get the person each on different groups. Okay, now let me show you an example. Now, okay, I am holding the name list of students here. So suppose that I want to do a random sampling. Okay, I want to randomly pick anyone. There are 34 students on list. Suppose that I want to pick anyone by random and then give the student a failing grade by random. Okay, so I just do a random sampling from number 1 to number 34. Now, suppose that I pick a number 22. Okay, so number 22 on this list, that student will get a failing grade by random. But suppose that I have 4 classes like this. Okay, then obviously in each class, I also need to do this kind of sampling to pick one student. Okay, but the systematic sampling means that, okay, once I get number 22 in the first class, I use this same number 22. So I go to the second class, whoever is on number 22, he or she will get a failing grade. So I'm not drawing another random number. I just use the random number that I get from the first group, and then I reuse that random number. So everyone who is the 22nd student on the list in every class will be chosen and given a failing grade by random. Okay, that is systematic sampling. And then you may ask, why do we want to do that? Actually, people do that because we want to reduce the cost of selecting the random number, because in the past, in the days where the computer was not very popular, it was really difficult thing to draw a random number, a really random number from something. That takes time. So people will think, okay, wow, it doesn't really matter who is on the list. So I just pick the first random number and we use that random number in every group. So that is systematic sampling. Now, nowadays, this is not a good thing to do, so do not do it. Okay. People do it because they want to be lazy, but we don't need that anymore because we can easily select a random number using the computer. Now, the last one, cluster and area sampling. Okay, how about this? What does it mean? So this one goes like this. Suppose that you are doing a questionnaire survey, but this time your population is every higher education student in Hong Kong. So it means that not only in this institution, but also in the other institutions. So suppose that you are distributing your questionnaire at this institution. So you go out and distribute your questionnaire to the students, ask them to fill the questionnaire for you. Okay, so you spend a few hours doing this here, and then you decide that you want to go to another university to do the same. So you take the MTR to Hong Kong U to do the same thing. Okay, distribute your questionnaire and get the data. But your population is every higher education student in Hong Kong. So it means that you also need to go to the other universities to do that. So you take the MDR to PolyU, you spend a few hours there, and then you take the MDR to CTU. Again, it's like, wow, so tired. Can I skip the others? Right? You don't want to go to HKUST or CU and then the Ningnan University, which is extremely far away. Right? You don't want to do that. So what about this? You think, okay, you make an assumption. So you think, okay, the students at the DI here are similar to the students at Hong Kong U here. And these students will also be similar to those at HKUST, City University, Ningnan University, BU, and so forth. So what if I skip all the other universities? They are so far away. Okay, and then you assume that the data that you collect from Hong Kong U, from DI, can be good representative of the data from the other universities. So you skip them, and that is a way for you to save your cost of data collection. Sometimes that is good because, like, sometimes the question you ask might not really depend on which university they are studying, right? So in that case, that is okay. But suppose that sometimes you are asking some questions, and that depends on the university. Like you're asking about, okay, what do you think about your campus environment? Do you like your campus? Of course, different universities have different campus. And you cannot assume that just because you like your campus, the students from Ningnan University will also like their campus, because that is a completely different campus. So you cannot represent them, the students from the other universities, using your data from Hong Kong U or from DI. Okay, so in that case, cluster or area sampling is not good. But in other case, if the question do not really depend on which university that they are studying in, then that might be a good thing to save your time and effort. Okay, so these are the 4 different ways of random sampling. Now, when you write your proposal, think about this carefully. Which way you want to do and why? And if you choose to do any one way, how do you justify your choice? And what would be the limitations doing that? Okay, you need to think about that carefully, because again, there is no way to come back once you collect your data in the wrong way. Okay, the bias is already there and there's no way for you to fix that afterwards. So very important thing to think about. Okay, so before I give you a break, I will talk about the data measurement. That this is another concept that is very important in data analysis. And the reason is that when you use SPSS or any other statistical software to analyze your data, you need to specify the levels of data measurement. So there are actually 4 levels of data measurement in the statistics. But for SPSS and for many other statistical packages, they only have 3 because they usually combine these 2 into one. The 2 at the top, they usually combine these 2 into one. Now, to simplify things a bit, I will only tell you the 3 types of data level. The first one is called the categorical data nominal level. The nominal here, this name, nominal means name. Okay, so example. Suppose that you are asking people about their nationality. Okay, so suppose that I ask, okay, we have 4 students here, but suppose that I ask only 3 of them just for the sake of simplicity. Okay, so I ask them, what is your nationality? Then the first one says that, okay, I am Chinese. So Chinese is 1 here, right? And the second one is British. And the third one is American. Okay, so 1, 2, and 3. Now, can you do the following calculation? Because we have 1, 2, and 3 here, and the mean value of 1, 2, and 3 is 2. Can we say that these people, on average, they are British? Can we do that? Of course not. But why not? Yeah, the numbers are not really numbers. The numbers here are just labels. They represent their answers. And I could as well use 1 to represent British, 2 to represent Chinese, 3 to represent American, and then you give a completely different mean value, right? Or conclusion. So the numbers here for this type of data is not meaningful because the data here, these are just names, and there is no particular order. Okay, you don't have to put the Chinese first. Okay, if you can put British in the front, okay, American in the second, and Chinese in the last. It doesn't really matter. This kind of variable is called nominal variable. And for nominal variable, you should never try to calculate the mean value of the answers. Now, I can give you another example, which I see a few times in the past in the students' report. Okay, so we analyze. We ask people about their gender, okay, male and female, and for example, okay, so and then they collect the data. They use 1 for male and 2 for female. So and then I see something very interesting in their report. They say, okay, the average gender of these people is 1.7. So it means that on average, these people are somewhere between male and female, but they are closer to male because 1.7 is higher than 1.5. Of course, we cannot do that, but I saw this many times in the students' report. Again, the reason why you cannot do that is the number 1 and number 2 here, they really mean nothing. They are just labels. And male and female, they are just names. There is no particular order in which you must place the male and female. You don't have to use 1 to represent male or 2 to represent female. And the numbers here are not meaningful. So you should never find the mean of the gender, like average gender. Now, but of course, if you just ask SPSS to find the mean or the average gender for you, SPSS will just give you the answer. It doesn't know what you are doing. So, and then if you don't know what you are doing either, then you just report the answer. Okay, then average gender is 1.7, which doesn't make any sense. Then you are dead. Okay, so this is the nominal level, and that's why it is important, because there are some methods that should never be done or applied on the nominal data. Now, another level is called the ordinal level. Ordinal level is also a type of categorical data. Now, ordinal, O-R-D, means order. Order. The order means that you have to put something in a particular order, such as age group. You ask people about their age group. So maybe 1 is 18 to less than 25 years old. And second, 25 years old to less than 30 years old, and so forth. So these are groups. They are names, but there is a particular order between these groups. You have to put the 18 years old in the front of the 30 years old, right? So this kind of answers with a particular order, and which is still some kind of name otherwise, is called the ordinal level. Another example of ordinal level data is income group, like what is your monthly salary? So you give them some range to choose from. Okay, and these are ranges, and the numbers, like a group 1, you put a label 1 here. Group 1 is like from 0 to 10,000. To less than 10,000. Like group 2 is 10,000 to less than 20,000, and so forth. Now, these numbers now, of course, you still cannot find the average, but you need to sort them into a particular order. So in this case, the order is important. Now, one very deep, controversial thing about ordinal level is something like this, Likert scale. So Likert scale is something that you may have seen before. Like you ask people, how much do you agree with something? So you give them a few choices, like a strongly agree, agree, neutral, disagree, and strongly disagree. Now, many people think that they can find the average of these numbers. But many people means even many researchers, they do this in their academic papers. But strictly speaking, this is wrong. This is wrong because when you ask them to choose from a strongly agree, now you just give them 5 choices to choose from. So these are 5 names actually. There is a particular order, but these are just names. Now I have written down the detail here, but I will skip this one. But in short, if you just ask them to choose their option from one of these 5 options, then this is ordinal level. And you cannot calculate the average of these numbers. There are exceptions sometimes, but most of the time this is wrong. But then you may ask, okay, what if I really want to calculate some average score? Then you need to adjust the way you ask your question. Now, instead of asking them to choose from strongly agree, neutral, and so forth, you ask them to give a score, like a score from 0 to 5. Give you a rating. Now, that rating is not ordinal. That is the next one. Okay, we call it the continuous number. So this really depends on how you ask your questions, and the different way you ask your question will lead to different level of measurement, and that will lead to a difference in the way you can analyze your data. Okay, so please pay attention to this as well. Many people, many researchers actually, they try to calculate the average of the ordinal level here, which is strictly speaking not correct. Not correct. Okay, so let's look at the next level. The next level in SPSS, we call it the scale level. They have, statistically speaking, we have interval level and ratio level under the scale level. But here I want to make it simple. I just call all of these the scale level. And the scale level basically means numbers, something that you can calculate the mean. The magnitude or the relative difference is also meaningful. Now, for example, if I just ask you the age group, so I ask you which age group you belong to, 18 to less than 25, 25 to less than 30. This is ordinal level. But if I ask you your age and ask you to give me one number, like I am 25 years old or I am 28 years old, that number is a scale level, because that is a single number, but not a range of numbers. Now, in that case, you can calculate the average of the numbers, such as the average age, right? You can do that, okay? These are numbers. But if you ask them to choose from age groups, then you cannot do this kind of average calculation, because these are a range of numbers. Okay, so in short, the scale level means numbers. You ask people about their height, their weight, some volume, profit and loss, revenue, age, income, if it is an exact number. Okay, that is scale. Yeah.
Age group 係應該計落邊
Age group is ordinal level, because age group itself, each of the groups is just a name, and there is a particular order in which you must arrange these groups. So that is ordinal. But age itself, a single number, is a scale level. Okay, so that is what I want to tell you in the lecture part. Now, at this point, I want to go back to the Kahoot and answer the other questions, and then I will give you a break and move. And then afterwards, I will move on to the SPSS demonstration. So for anyone, if you just joined, you can go to Kahoot, and enter this number to join the quiz. Okay, now let's move on. Wow. Okay. And these questions are about the lecture. So which of the following sampling method is more suitable for quantitative analysis? Random or non-random? Yeah, so quantitative method, in quantitative study, we should do random sampling. And the reason is that we want to generalize our findings. So we want to make sure that our sample is a good representative of the population. So we need to do this by random. Okay, next one. Oh, okay. You want to draw conclusions about the sample only, then which type of statistics should you use? About the sample only. Yeah, descriptive, because you draw the data from the sample and then your conclusion is also about the sample. You are not trying to make any guess about the population. So this kind of, in this situation, you are just describing what you have. So this is the descriptive statistics. Next one. Okay, you want to generalize from sample to population. Which type of statistics should you use? This one should be simple. Okay, yeah, inferential statistics, because by definition, infer means you want to make a guess. And you want to make a guess because you only have sample data, but you want to talk about the population data. That is what we call generalization. And we want to do inferential statistics. Okay. Which of the following is not true about sampling? This one is a little bit tricky, so I give you 60 seconds. Yeah. So for this one, let's look at the other options. Now, sampling is bound to produce error. This is true. Because when you select the 5 ducks out of the 20 ducks, it means that you are ignoring the other 15 ducks. So obviously, you don't know anything about those 15 ducks, and that will lead to error. Sampling always produce errors. Now, the blue answer, random sampling should be used in statistics. Of course, that is true. We want the result to be generalizable. The green one, non-random sampling should be used in qualitative analysis. That is true as well, because I want to pick that particular person who I think will give me a deep understanding of the topic, okay, in the qualitative study. So that should be a non-random sampling. And the yellow one sampling is only used in inferential statistics. Of course not. Even though you are only using descriptive statistics, you still need to do sampling. But the difference is that you only draw your conclusion about the sample rather than the population. So yellow is the answer. The next one. Okay, what is the level of measurement for student name? So I have a data, a variable, which is the name of the student. So which level of measurement is it? The student name. Okay, now nominal. Yes, the student name is nominal because it is just name. And some people may say, wow, there is an alphabetical order in a name. But in statistics, the alphabetical order is not an important type of order. So for name here, we usually consider it just a nominal variable. Okay, what is the level of measurement for age? Age, not age group, age. A single number. This one looks to be a little bit tricky to some of you. Now, age means I ask you, how old are you? You say, okay, I am 18. So 18 is the answer. Age group is another thing. Age group means like 18 to less than 25. But here I am asking about the age and exact number. So first of all, this is not nominal because it is a number and there is some particular order. And it is also not ordinal because these numbers, it is meaningful to find the average of these numbers and average age, for example. So this is scale. But if you ask the age group, okay, then that is ordinal. Okay, but for this one, it is scale. Wow, it is ordinal. Okay, I don't know what it means anyway. Okay, now the last question from this part. What is the level of measurement for Likert scale? Like you ask them whether they strongly disagree, or neutral, or agree, or strongly agree with something. Okay, good. That is ordinal level and not scale level. Now, if you ask them, can you give me a rating to represent how much you agree with a statement? And 5 means 5 means you agree with it very much, and 0 means you do not agree with it. And then you ask them to give any number from 0 to 5. That is scale level. You ask them to give you a rating, a number. But if you just ask them to choose from one of the 5 options, although you assign numbers to represent each of them, this is still ordinal level. Okay, this is a very common misconception among the academics, but this is, strictly speaking, this is ordinal level. Okay, now please put this aside and I will come back to this later after the SPSS demonstration. So now I want to give you a break for 5 minutes and then we come back after 5 minutes. Thank you. And for those of you who are joining it online, just for the sake of recording the attendance, please go to the home the first page and then click this link and sign your attendance, just in case. Okay. Okay, we take a break for 5 minutes.有冇現場？未點名係嘛？唔該。Thank you. Okay, everyone, let's move on. For students from online, if you are back, please raise your hand in Microsoft Teams so that I know you are here. Thank you. Good. Okay, thank you. So now let's move on. Now in this session, I am going to talk about SPSS. Now for those of you who are using, who are attending online, I know you may not have SPSS installed on your computer, but I just want to tell you about the alternative that you can use to analyze your data. Now you can go to the first page of our website. SPSS is one of the software that we use to analyze the data. The problem, or actually a characteristic, not really a problem, but a characteristic of SPSS is that it is a commercial software. It is not free of charge. So I suppose you do not have the license to use it at home, right? And you have the software here in the computer lab, but you do not have the software at home. Now, so in this class here, in the past, a few months ago, I delivered this class entirely online because at that time, the pandemic was very serious. And of course, now it is also very serious. But at that time, everyone was doing this course online, and they do not have SPSS at home. So that's why at that time, I also taught another software. That software is called Jamovi, and you can find the name here. Now, SPSS is not free, and if you really need to use SPSS at home, you can use the 14-day free trial, but notice that once your 14-day trial expires, there is no way for you to use the trial again. Even if you use a different name, or even if you think you uninstall the software, somehow it knows that you have used your trial on your computer, unless you format your computer or use another one. So do not use this trial unless you really need to. So suppose that you are in a hurry and you need to do something on SPSS and tomorrow is the deadline of your report, then you can install the 14-day trial. But please don't do this now, because if your trial expires, then there's no way for you to do this again in the future. So an alternative that you can use is the Jamovi. Now you can click on this link here. So this is the Jamovi. Oh, they even have online demo now. I didn't know that. Online demo, good. So this software is very much like SPSS. Oh, good, that is a complete demo. So in a sense, this software is designed based on or by kind of copying the design of the SPSS. So they look very similar. And just in case someday in the future, you need to analyze some SPSS data, but you do not have SPSS at hand. A very good thing about this software is that it can read and write SPSS. Okay, I'm not sure about the writing, but it can read SPSS files. So, and also it can produce similar output in similar ways as SPSS. So this is really a very good alternative of SPSS. So someday in the future, suppose that if in the next semester there you want to, if for some reason you cannot come back to the computer lab to do your data analysis, you can use Jamovi. And this software is free, open source and free of charge. And if you want to use it, you should download the current version, which is the latest version, rather than the solid version. Okay? Download this one. So if you are using Windows You download 1.6.7. If you are using a Mac OS, again, 1.6.7. If you are using Linux, again, 1.6.7, and so forth. So this is a good alternative just in case you cannot use SPSS. Now, there is another software called the R or an R Studio. Now, this one, you can also click into this link to take a look at what it looks like. The R here is more difficult to use. In a sense that you can look at the screen here. Now the R here, of course, it can do a lot of things. But the learning curve is also quite steep for this one. As you can see here, okay, this one maybe. This software is also very powerful, but it is also very difficult to use because you need to do some programming in order to use it. But R is the software that many advanced researchers use for their data analysis because it is most flexible and most powerful, but it is very difficult to use. But anyway, just want to let you know these names of the different alternatives. So my recommendation is that, of course, you should use SPSS. But if you, for any reason, you cannot come back to the lab to do your data analysis, and you can either choose use the 14-day free trial, but you can only use it once. And alternatively, you can also download the Geomorphic, which is open source and free of charge, and it looks very much like SPSS. Okay. Now, but for here, I want to use SPSS as the demonstration. So if you have SPSS, please start SPSS in your own computer. You can do it by just typing SPSS in the start menu. But if you don't have SPSS at home, you may just simply watch my demonstration on the screen. Okay, for those here, please open SPSS. We do something together. And the screen will look like this. So 係第一個 SPSS Statistics 25 for those of you working in the lab. And for those of you attending online, if you don't have SPSS installed, then you may just watch the demonstration on the screen. Okay, now one more thing to tell you. If you click into the introduction page, scroll down a little bit, just below the link to the lecture notes, you'll find supplementary information for data analysis in SPSS. Now you can click open this link, which is Google Doc. Now this document is something that this will give you basically all the details of all the steps that most of you are likely to do on SPSS. So for example, if you scroll down this document, you can see the basic operations of SPSS, like how to create a data file, how to open it, or how to import the data from Google form or from Excel file. And I even write down some common problems, like many of you might be using an online questionnaire using Google form. Now, in that case, sometimes you will run into problems if there are Chinese characters in your questionnaire or in your options of in your data. And this problem is due to an incorrect Chinese encoding in the data file. I think Google is responsible for that. I think there is some problem in the way that Google deals with the Chinese characters in the dataset. But anyway, there is a way to fix that. I will not go into detail here, but suppose that someday in the future, you find that your SPSS cannot open your data file. It tells you that the data file is empty. Then that is most likely related to the Chinese characters. And I have written down the solution here. So you can just follow the solutions step by step to fix the problem. Now below here, I also talk about the data editor. And then below it, I talk about data preparation, how to do descriptive statistics. That is the topic of next time. And also how to do inferential statistics. And that is the topic of next time. Okay, so basically in my demonstration, I will follow what is written here to guide you through the SPSS user interface. And if you have SPSS, please follow me step by step, or otherwise just watch the screen. Okay. So what I want to do here is for you to look at the SPSS interface here. So this is the data editor. Now this interface looks very much like Excel, right? So let's just enter some data into here. Now, I am going to demonstrate how to enter data manually into SPSS. But of course, in the future, many of you are likely to be just importing data from an Excel file, but it doesn't matter. Let's just go through the basics. So in each column here represents a variable or a question in your questionnaire. And each row here represents one record. So let's now just input some number, okay? Just type in any number you like. Okay, we put in 5 rows of numbers. Okay, any number you like. So when you enter some numbers into here, you see that you have a name that is a very interesting name, VAR, and then 00001. Next to it, we find an icon here. I will explain to you what it means later. And then we have 5 rows of data. It means that we have 5 respondents. So you send out your questionnaire and 5 people return the questionnaire to you, and then you have 5 rows of records. And we also call this the case. We have 5 cases here. Now, and then in the second column, let's also type another column of any data that you like, numbers. Okay, so this is an SPSS data set, and it looks really very much like Excel. Now, but I want you to compare this with Excel. So you know Excel is something many of you are familiar with. Okay, in Excel, of course, we can also enter numbers like this. Okay, but I want you to compare this and tell me what is the difference between the SPSS user interface and the Excel user interface. Is there anything that you can do in Excel but not in SPSS? Now, please try it. For those of you who are using, who have an SPSS at hand, please try to do something that you usually do on Excel and see if you can also do this in SPSS. And then tell me the difference between the two. You cannot type the words, right? 即係文字係咪? Or actually, you mean something like this, right? Actually, you can do that. Yeah. But you cannot do that if you already have numbers here. And if this icon looks like a ruler, you cannot do it. But I will explain to you why. But actually, you can do it. But you have pointed out a very important point, and I will elaborate that further in a while. Okay, anything else you can do in Excel but not in SPSS? Formula. Okay, what do you mean by formula? Equal. So suppose that you try to do something like this. I want to find the sum of the two numbers. So what you usually do is to put an equal sign here, right? And then for two numbers, you enter the coordinate of the number. Something like this, right? This is how you find the sum of something in SPSS, sorry, in Excel. And you enter it, and then you copy the formula downward so that it will find the sum of everything, every record. And you can even change the number here. Like if I change the number 5 to number 1 here, then the sum will also change, update automatically. This is what you can do in Excel. But let's see if we can do the same in SPSS. So first of all, you find a difficulty. At the top of the Excel here, you find the ABC coordinate. But here, it doesn't look like coordinate, right? So that is one crucial difference. But anyway, let's do the formula anyway and see what happens. So I go to here. I input the equal sign. So let's say we just input A1 plus B1. Okay, equal A1 plus B1 and see what we get. And then it gives you equals A1 and plus B1, right? So obviously, the SPSS is so dumb here. It doesn't know that we are going to do some calculation, right? And maybe you say, oh, let's enter the variable name instead. Okay, so let's enter the variable name instead. VAR 0000. Okay, it turns out that it doesn't allow you to enter anything beyond that. Yeah. Okay, maybe the length problem. I clear this one and do it again. Now, this one, VAR 00001 plus VAR 00002. And then let's see what we get. And then we get the formula. It's so dumb. It doesn't. It's not really doing any calculation. Okay, anything else you can do in Excel but not in SPSS? It looks like there are a lot of things you cannot do here. Like in Excel, you like to right click and choose the number format or choose the color. And in SPSS, we right click. Okay, and we see a lot of options, but none of them look like you can change the color or you can change the font size and so forth. Okay, there's nothing like that in Excel. Now, this is a very important demonstration that tells you that although SPSS looks like Excel, it really is not working in the same way. Now, but there is a reason for that. I can tell you that in SPSS, actually, you can find the sum of two variables. But the way to do it is not to type the formula here, but you go to the transform and go to compute variable. And then here, you write something like this. You enter the formula here. Don't worry, I just give you a demonstration. Later, I will come back to this again. Okay, so you need to enter the formula here, give it a name, and then you add the sum to the data set. But after that, if you change your original data, SPSS will not update the sum. So that looks very dumb, right? But the reason is that, think about what SPSS is for. Yeah, statistics. What Excel is for? Yeah, spreadsheet. Spreadsheet, of course, involves some calculation, right? Now we say that Excel is a calculator. Of course, calculation involves statistics, but it is not only for that. And Excel is usually used to deal with relatively small data sets. But SPSS, we usually deal with large data sets. Now, so imagine what happens if you have a very large data set, like 10,000 records. And then you change one number, and then you wanted to update the formula in real time. That is, yeah, or will die, right? So that is a huge computational load in the computer, and then Excel will just simply freeze or die. SPSS do it in a different way. In SPSS, you may find that SPSS does not look very user-friendly compared with Excel. Right? It is not as flexible and as intuitive as Excel. But SPSS is good for dealing with a large number of data. And SPSS is also good in dealing with the different levels of measurement. Now, in Excel, there is no way to define the different levels of measurement. Level means ordinal, nominal, and scale. But in SPSS, it deals with these different levels, and so it can give you different responses in the analysis based on what data you have. So that is a very good thing. Maybe not for someone who just want to do some casual calculation in the spreadsheet, but it is very good for data analysis. Okay, so here, you know, these two softwares are different. Now let's see, try to explore a little bit more by following my steps here. So the basics. Now, basically in SPSS, if you want to create a data set, you simply do what we have just demonstrated. We will just enter the data directly. Or you can click on the open data document icon here. And then you can open the SPSS file. And if you choose an Excel file, then if you have an Excel file here, you can open or you can import the Excel file into SPSS format right away. And this is useful when you want to export your data from Google Form or other online questionnaire. And then you export those data in Excel format, and then you import the Excel file into SPSS. So you don't really need to input the data manually in that case. Okay, so this is what how we open, create, and import data. So what you see here, this window is called the data editor. The data editor. But in the data editor, if you go to the lower left-hand corner, you see there is actually a data view and variable view. Now, data view is what is the interface that looks like Excel. But you can also go into the variable view. You see that you have another window, another view that shows you the information or the definition of each of the variables. This is, again, something that Excel does not have. And if you want to analyze your data, then it is better for you to define your variables. Now, in Excel, you simply type the variable name and nothing else. But in SPSS, you can define the variables. Now, in this screen, you can do a lot of things. For example, you can rename the variables. So if you don't want it to be called VAR00001, you can just click on here and just type the question number or the variable number here, and then it will change. And in this way, you can change all the variable names. So that is really convenient. If you go back to the data view, you see the name is now changed. Okay, very convenient. Now go back to the variable view. There are some other features. I will go through them in detail later, but I just want to let you know this one. Measure. Now go to the measure here and you click on the original value is unknown, but if you click on it, you see these are the levels of measurement. So I said that it is important for you to define the level of measurement, and this is where you can do it in SPSS. Now, here we have 3 icons. The first one looks like a ruler. That is for scale. Scale, you remember that scale means numbers. And second is ordinal. And the third is nominal. So now for our case here, suppose that and you have to design which level of measurement you want to use for this variable. Now, but for our case here, let's just assume that both of them are numbers. So we set them as scale. Scale and scale. So if you go back to the data view, now you know the meaning of this icon here. This icon means scale variable. If you have another variable like the gender, then you want to set it to nominal. Okay, very important. If you set this wrong, then some data analysis will be wrong. Now, although it is not like Excel, there is still something similar to Excel that you can do. One thing is that you can go to the window, and then you can click the split menu. Okay, so the split here means that you split the screen into 4 parts here, so 2 in each direction. Okay, so why is it important? Because sometimes you are dealing with a large data set. Now we only have 2 variables and 5 records, so you do not really want to split the screen. But sometimes if you have a really long data set, like 1,000, so sometimes you want to see parts of the data here, like the first record, and at the same time you want to see another part of the data here. So you see in the upper half, we see the data set, and in the lower half, we scroll to the last record. So you can look at different parts of the data set at the same time. That can be very convenient. Do you know whether you can do this in Excel as well? Yes, you can do this. You can do this in Excel. You can try in Excel later. Now, horizontally, suppose that you have a really large data set with a lot of variables. So sometimes you want to look at 2 variables at the same time in one screen. And you can, again, the splitting will help you. Oh, by the way, just if you wonder, in Excel, if you want to do the same, you can go to the view and then find the split button. You can also do the same. Okay, Excel. Okay, so to cancel the split, you can go to the window again, or you can also go to this this window here and go to the remove split. Then you will get back to this screen. Or alternatively, you can just go to here. You see the 3 dots here. You go to this splitter, double click, and then it will go home. Double click. Okay, this is one handy feature that you may want to use sometimes. Now, you can also sort your cases, or you can also, sometimes you can also filter your cases. Now, to solve the cases, you go to the data here, and then you go down to find this option, data, and then sort cases. And you click on it. So here you need to choose which variable you want to sort by. So if I want to sort by variable 1, then I put this variable onto the right-hand side. Now in SPSS, it always works like this. You want to do something on some variable, then you pick the variable and put it onto the right-hand side. Down here, you have the sort order. Like if you want ascending, then you just choose the default value. If you want descending, then you see this letter here becomes a D. Okay, so let's do an ascending sort. Okay, and then click OK. So after that, you see another window popping up. This is the viewer, and the viewer here is just the window that shows you the output, or it also shows you what the SPSS has done. Now, and then go back to the data editor, and you see that my data are now sorted by question number 1. Okay, now another thing you can do, which is also very convenient, is to select the cases. Select cases. Now you can select the cases by going to the data and go to the second last option. Select cases. Now go to the select cases here, and then again, you see the variables. And now on the right-hand side, we have a few options. The default one is all cases. It means that you do not select any case, or it means you select everyone. But now let's try to find, set some condition. So I choose the second one, just as an example. And then if we click the if means that you want to set some condition. So let's say you look at my data. Q1 here, I have 3, 4, 5, 5, and 6. Now suppose that sometimes you only want to analyze the records with a particular value in the variable. Like if I only want to choose analyze the record in which the Q1 answer is equal to 5 in this case, then what I do here is to go to the left-hand side of this box, put the Q1 onto the right-hand side. Okay, I want to do the equal side here. I only want to analyze or choose the number, the records that with the value of 5 in Q1. So Q1 equals 5. And then we click continue here. So you see the condition here, Q1 equals 5. And then we click OK. Do you see that? Some records are now crossed out. Records are now crossed out because they do not satisfy the condition that I am going to check. Okay, and only 2 records here remain. And now, if I do any analysis to the data set, SPSS will automatically ignore all the records that are crossed out. So this is a very convenient feature. Sometimes you don't want to analyze your whole data set. You only want to analyze some of them. And by using the select cases, you can easily select some of them. Now, suppose that you want, after you do some analysis, you want to go back, you want to do another selection. Then you go to the data here. You go to select cases again. This time we click the if again, and suppose that you want to find something that is smaller than a certain value. Now, depending on what you have entered, in my case, I want to find select all the records with Q1 smaller than 5. I click continue. So the condition is changed here, and then I click OK. So do you see that this time we have another way of selection. So only the first two records are selected and the other records are crossed out, because in my case, only these two records satisfy the condition. Now, at the same time, you see that as I do the selection, SPSS has automatically created a new variable for me, and this is what we call the filter variable. And the filter variable, the value is either 0 or 1. 1 means that record is satisfying the condition, and 0 means not satisfied. But in my case, we do not really need that. So usually I would just delete this variable afterwards. Now, okay, so suppose that you do some analysis here, and again, you want to cancel the selection. So to cancel the selection, you go to data again, go to select cases. This is one way to do it. Now, but I want to show you another way. Sometimes you are feeling a little bit lazy. You don't want to go through this menu and click through this again, or sometimes you simply forget what you have done before. Now, in that case, you can go to this button. This button is the we call recently used dialog. Click on it, and then you see all the menus that you have used before can be found here. Now, let's select cases again. So this time I want to cancel all the selection, and the way to do it is to go to the all cases. You don't have to delete the condition. You simply go to the all cases and then click OK here. So you see in this case, all the records are now available. And in this case, I would usually also remove this extra variable. To remove the variable, you go to the top here and click on it. And then you right click and clear. So that will remove the variable. Okay, so these are just some of the basic operations. Now, for the split file, I will go through it later in my descriptive statistics demonstration.
我想問咧，有冇方法可以整兩條？即係譬如我如果 V1咁樣啦，咁然後 V2有另一個啦，咁我應該點樣？
即係兩個條件係咪？兩個條件通常我哋就會 set 做頭先咪有個 filter variable 嘅，個 filter variable 就記錄咗佢係咪符合某一個條件，然後我保留嗰個 filter variable， 我再做多次另一個 filter， 咁我咪有兩個 filter variable。然後你個 condition 就係嗰兩個 filter variable 同時等於1。嗱，你用 and 都得，你一個做晒都得嘅，不過通常我會分開去做會好啲。So, okay, for the split variable, I will go through it later. Now, after doing all this, we have not done any data analysis yet, right? So what I have shown you is that you can enter data here, you can define your variable, or you can filter your variable, sort your variable, but how to analyze the variable? Anyway, after all that is the most important thing you want to do. Okay, so the way to analyze the variable is to, if you want to analyze Q1, then you just click on any cell under Q1. Go to the top here and find this button. You know how to pronounce this Greek alphabet. This is not U. This is the mu. And the mu represent, in statistics, the mu usually means the population mean. But in here, it means analysis. So just click on this button. And ladies and gentlemen, this is the analysis. You get it in less than 1 second. So that's why I said in the beginning that calculation is really not important. If you worry about how to use your pocket calculator to find a mean or something, then forget that. You don't need that anymore. Okay, throw away your pocket calculator. That is not useful here. So you just click on one button, and then it will give you the average value, the median, the standard deviation, the range, the minimum, the maximum, all of them in just one click. So that is the easiest way to analyze your data. That is not the best way, but that is the easiest way. You just click on it and then it will do the analysis for you. But next time I will tell you how to do it in a better way, because here you just click the button. That is pretty fast, but you cannot control what you want to do. It just gives you what it thinks that you want, but that is, sometimes you want to have more control over how you analyze your data. But that is the topic of next time. Now, so at this point, you have already gone through some of the most important operations or basics in the SPSS. Now, I can also tell you that the most useful manuals in SPSS, there are basically 4 manuals that are the most useful. The data is the one that helps you deal with the data, such as you want to sort your data or you want to select your cases. So all of these can be found under data. The transform manual. Transform means you want to change something, right? So sometimes, like I show you that you can use the compute variable to find the sum of some values, right? That is how you change your variables. And another manual that we are going to use later today, in a moment, is the recode manual. Okay, we will also do that. And next time, we'll really start doing some analysis. And analysis, of course, you should find it under the analyze menu. And one of them, you see the name here, descriptive statistics. This is where you do the descriptive statistics. And for the inferential statistics, such as the t-test or the ANOVA that you may have heard about, they can be found under the compare means. And other type of inferential statistics that I am also going to cover in the next lesson is called the non-parametric test. This is also something very important, in particular for the ordinal data. And you can also find it here. So analysis itself is really not difficult. What is difficult is you need to pick which option you want to use, and you need to know how to interpret the data to answer your research questions. These are the themes of the next lesson and the next lesson, but today let's just focus on something simple. Now, finally, if you want to do some graphing, you can go to the graphs menu here. And we usually just use the chart builder. Again, we are going to do this next time when we work on the descriptive statistics. Okay, so at this point, I have finished the SPSS user interface guided tour. And next, we want to do an exercise together. Please, by the way, let's finish the Kahoot first. We have a few questions for you to answer. Okay, go back to the Kahoot. And let's finish the remaining questions. Okay, let's see who is leading now. Okay, Alex is still at the top. Okay. The next one. Okay, what is SPSS? What is SPSS? Yeah, good. I think I don't need to explain this, right? Okay, the next one. 呢個有團火。Okay, how can you enter data into SPSS for analysis? Yes, yeah, all of the above. Now, I think this one deserves some further explanation. Now, of course, you can enter the data manually in the data view of the SPSS, so the blue one is correct. The red one, you can import from an Excel file. That is also possible. Of course, because sometimes you really want to import your data from the online questionnaire software. You don't want to input them by hand. The yellow one is also correct. Now, but you may ask what it means by CSV format. So CSV format is something very simple and yet very important, or sometimes very helpful. So CSV format, basically, you put your data into a simple text file and you separate the different columns by comma. That is the CSV. The full name is comma separated values. So you may ask why sometimes you want to use the CSV. First of all, in Google Form, if you want to export your data, the format that I recommend is the Excel format. But another format that is also possible is the CSV format. CSV format is very simple. And sometimes you may run into technical problems with your data set, even though if you follow the workaround that I put into a document to deal with the Chinese characters, even though you do that, sometimes you still fail because the Excel file may be somewhat corrupted. So in that case, the only way to save your life, to save your data, is to export the data as CSV format. That can also be imported into SPSS. The CSV is some kind of lifesaver. If all the other ways fail and you cannot import your data, then the last thing you can try is the CSV. If the CSV still fail, then congratulations, you go back to do this again. Okay, collect your data again. But CSV sometimes can be very helpful. Okay, next one. Okay, where can you edit the variable properties in SPSS? Remember what we have seen in the demonstration? Yeah, the variable view of the data editor, which means here, this is the variable view, and here you can edit the variable properties here, including the level of measurement and other properties. Okay, next one. Okay, where can you input and edit data in SPSS? This one should be simple. Yeah, data view of the data editor, which simply means the screen that looks like, but that is not the same as the Microsoft Excel spreadsheet. So this is the data view. last three. Okay, what does Windows and then split do in SPSS? Yeah, good. So it splits the data field into two halves. By the way, there is another function in SPSS that can split the data file, but I will do that next time. Okay, next. Okay, last two. Which of the following features in Excel are also available in SPSS? This one should be simple. Yes, the data view is this view that is similar to Excel, and you can enter data here. But in SPSS, as I show you, you cannot enter formulas like this. And even if you input the formula in some other way, the cell values will not be updated automatically. But I also explained to you that this is reasonable design because you want to ensure that you can deal with a large data set, right? So that is actually a good thing. Now, the last one has not been covered yet, but let's go through it anyway. Wow. The last one, which of the following steps comes first in data analysis? Actually, I mentioned it briefly earlier today. Okay, now this one is a little bit controversial among yourself. Now, what is the first step? Let's look at the red one. Do the inferential statistics. Of course, that is not the first step because before you can do your inferential statistics, you need to process your data first. So the red one is certainly not the answer. The yellow one, report the findings, of course not. If you can report the finding right away, then why worry about the statistics? The green one, export the results to a Word file. If you have the result already, then why worry about the statistics? So green one is obviously not the correct answer. The blue one is the correct answer, to clean the data. Now, to show you how to clean the data, I am going to give you my last demonstration today. But first of all, let's see who gets into the top three. Okay, number 3, Jackie. Okay, Yoku, number 2. And number 1. Okay, Alex. Okay, congratulations to all of you who get into the top 3. Let's let them stand for a while. Now, so I have about 30 minutes remaining, and I will go through another demonstration with you together. So to do this demonstration, all of you, if you have SPSS at home, you can go to here, introduction, and scroll down to the data pre-processing exercise. And here you have a worksheet. Now please download this worksheet, open it. And also download the unclean data set. By the way, if you don't have SPSS, then just watch the demonstration here. The unclean data set is an Excel file. It is an Excel file, so you can download this one into your data set, into your computer. Okay, now let's look at the worksheet first. Now, the idea behind the data pre-processing is that you need to deal with the errors in your data set before you actually start working on your data. Now, you may ask what kind of error you have. In fact, there can be all kinds of problems in the data set. Now, here I have an example. Now, this is the same as what you download. Now, look at the data set here. This is a simple data set, but this data set is full of problems. In fact, I have put in at least six types of problems into the data set. Now, everyone, please look at the data set and tell me what kind of problems you find in this data set. Empty data, we call this missing values. So here, obviously, we get something here, like a question 2 in case 7. You find that this one is empty. This is called a missing value. Anything else? Any ideas from online students? Categorized into oh, sorry, what? Now maybe look at here. Okay. Okay, there's an S here. The S here, this one, this is obviously not missing value, but it doesn't look correct, right? Because all the other values are numbers, but now you get an S here. How you get this? Oh, sorry, I hear someone playing the news. Sorry, I have to mute you. Okay, so now, okay, the S here is an invalid value, something that should not be here. Okay, anything else? The name, the variable names are not consistent, right? This is now, in fact, in terms of the use of SPSS, this really is not a real problem, but we do not usually allow this type of inconsistency because that is first of all, that is ugly, and of course, and also that might lead to some other error or mistakes being made afterwards because the name of the variables are not very clear. Okay, Q7 have extremely large value. Which one? Which value do you think is large? Extremely large? The 7. Yeah, the last question has value number 7 in case 11. But that is actually not, that is not necessarily a problem. Now, of course, I know what you mean. Sometimes we have extreme data, but extreme data is also data, right? And in this case here, we will deal with this kind of things later, not in the data cleaning process. Good attempt, but we deal with something else here. Okay, one more thing. Do we have correct ordering of the variables? 第三題嗰小數位 not necessarily. The decimal places you mean in question 3. It depends on how you want to present your data, and it doesn't matter here. Look at the ordering of the questions. Which one comes first? We have question 1 here, question 2, 3, 4, but why is it not question 5? Right? This is 6 in front of question 5. So of course, it's not illegal to do that. But again, you are setting a trap for yourself, and it will sometimes you might run into problems because of that. So we usually arrange all the variables in their correct order. Now, the first column here. for every variable, we should give a name, a meaningful name, so that you look at this name and you know what it means. But here we do not have any name for this variable. So this is also a problem. Now, okay, so we have five types of problem, but there is one more problem that is not obvious by looking at this data set alone, but instead we look at the table below that. So usually when you design a questionnaire, you have some kind of valid range of values. Like if you are asking for male and female, you don't want a third value. And sometimes like you want to define like a question 1, you want to only accept 1, 2, and 3. And question 2, you want only accept 0, 1, and 2. Now look at this table and look at the data set. You think there is any problem in the data with respect to the valid values? Yeah. Question number 2, what's wrong with that? Yeah, the 3 is not acceptable in question number 2, right? Now, let's look at these value ranges. Question 1, question 3, question 4, 5, 6, 7. These are okay, even though you may say, okay, we have a 7 here. In the last question, the 7 is still a valid value in here. Although it looks strange, it might be some kind of other, like an outlier, but it is still valid value. But question number 2, obviously you should not accept number 3 here in the data set, right? So because the valid values should be either 0, 1, or 2. Now, this I have seen this multiple times in the students' data in the past. And usually that mistake is due to maybe if some people are working as a group when they enter data. So one of the students define the range of values to be 0, 1, and the student thinks that, well, I want to input 1, 2, and 3. Okay, so that is a problem, right? Then that becomes inconsistent. Now, so this is also something that we want to fix. And of course, sometimes if there are only 1 or 2 values that are invalid, then maybe that is just an input error. But in other cases, you need to check very carefully why there was a problem. And usually we need to go back to the original questionnaire if it is a paper-based questionnaire. Check the questionnaire and see whether it is your mistake or it is the participant filling in the invalid value. We need to check that. Okay, so now let's see how to fix the problem or how to clean the data to fix all these problems. So first of all, we open another data file. And after you download the Excel file, you can go to the files of type option here and choose Excel from the format. And then you go to the folder where you put your data file. And in my case here, it should be in the download folder. So this is the Excel file. I click on it and then open it. So opening an Excel file is usually straightforward unless you have Chinese characters in your dataset, but we will deal with that later. Now, in this dialog, it asks you about the settings, okay? And usually we just check the preview here and see if it looks like the data are correct. Everything is here. Okay, and then we simply click OK. So that is how you import the data from Excel. Very simple, very straightforward. Okay, now when you import the data from Excel, SPSS has also performed some automatic correction for you. Now, let's say you look at the data set here again. You remember the invalid value of S here in question number 4, in case 15. Now check my data set again. Question number 4, page 15. You see the S is gone. Now the S is gone because SPSS, it has some kind of intelligence here. It checks all your other values and it thinks that, well, all the other values are numbers. Why do you have an S here? So it thinks that this one is wrong. So but it doesn't know that what it should be. So it just remove it and make it a missing value. But the other problems are not fixed automatically. So in what follows, I will show you how to fix the problems. And if you have SPSS, you can do this together with me. Now let's do the easy things first. We go to the variable view. You see the names are very ugly, right? So we fix the names one by one. So Q1, my practice is to give the question number rather than the variable number. So I don't usually put variables like the age or the income here as the name of the variable, because in that way it would be a little bit difficult for me to find the corresponding question in the questionnaire. And it is also difficult to find the corresponding variable if you have a long list of questions. That means you have many columns. But if I label everything with the question number, then it's easier to find them. Anyway, just a personal practice. You don't have to follow this. Okay, now this is the Q3 and then Q4. Now notice that this one after Q4 is Q6. And then we have Q5. And the last question is Q7. Now, on the right-hand side here, you see the label. The label is a description of your question. So this is the place where you can put down some descriptive label to show yourself and to show other people what this variable means. So let's say, if you say, okay, I want to show that question number 5 is gender. Okay, question number 5 is gender, right? So if you want to remind yourself that then this is gender, then you can just put the gender here. Yeah. So that you look at the data later, then you know what it means by Q5, okay, and so forth. Okay, so this is how you set the variables. Now, and we also try to fix the name of the first one. The first one is actually the case number. I would say that means when you if you are doing a paper-based questionnaire, then every time you input the data into one record into SPSS, you also mark a number on that questionnaire. So that is number 1, that is number 2, and so forth. So this is helpful because if someday, like you see that there is empty missing value here, then you want to check your original questionnaire to see if there is really a missing value there, or you just forget to input that. So you go back to the question number 7, questionnaire number 7, and see the original data. But of course, if you are doing online questionnaire, then you don't need that. Because in online questionnaire, you have a timestamp in the front. You see the date and the time that where you can find the data. Now, another question you may ask is, we already have number in the front, right? Then how come we need another variable to represent the questionnaire number? Why? Yeah, you can sort all the data, and when you sort the data, you lose all the information about the questionnaire, the case number. So we need another variable to represent that. Now, the default name given here is V1, but we don't want V1. We want to give a more meaningful name. So this time, let's double click at the V1 here, and then it will go back to the variable view. Now, my practice is to call it case. Now, notice in the name in a variable name here, you should not include any space into the variable name. Look, so let's say if someone wants to do that, if you say, okay, it's case number, so why not just call it a case number? And if you do that, you get an error message because variable name contains an illegal character. In this case, the illegal character is the space. So you should not do that. If you really want to merge two words together, then you can do something like this. Just put them together and separate using the uppercase. But I would usually keep it simple and just call it the case. Okay. And then we also change the ordering of the data. So Q6 should be after Q5. Now we go to Q5 here, click in front of it, release your mouse button, and then click on it again, and this time drag it upward so that it is in front, the red line is in front of Q6, and then you release your mouse button. Right, so this is how you change the order of the questions. Now let's go back to the data view to see how it looks now. Q1, Q2, Q3, Q4, Q5, Q6, and Q7. Okay, it looks quite good. Okay, let's fix the more difficult problems. Now, and then we go to here, which we deal with the more difficult problems. So let's look at the level of measurement. The level of measurement, as I explained to you, is very important. And in my data here, the first variable should be ordinal. The first variable means Q1 here. So we need to set all the variables. We need to set all the levels of measurement to make sure that they align with our questionnaire design. Now, for the case number, the first one is the case number. The case number, actually, it doesn't matter what you use for the case number because we never analyze the case number, right? I don't want to find the average of the case number. So I usually just keep it nominal, the default value. But it doesn't matter anyway. The second one, the second row is Q1. Q1 should be ordinal, so I change this one to ordinal. And then ordinal again, and then scale, and then nominal, 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 and the last one is scale. So it is very important to set the level of measurement. Now go back to the data view. So you see after all this, the data looks much better now, except one thing. Q2 is not correct, as I pointed out. So Q2 is not correct because the valid values are 0, 1, and 2, but now we have 2 and 3. Now, how to fix the problem depends on how you make the error, right? So if it's just if you just remove the number 3 here, that's fine. But you need to check your original questionnaire. Did people really enter something like the third option, or it is just a matter of input problem? Now I want to assume the following. I assume that it should really be 0, 1, and 2, but when the student could enter the data, he or she mistakenly thinks that it should be 1, 2, and 3. So that's why we have a lot of 3 here. Now we want what is to convert the 1, 2, and 3 back into 0, 1, and 2. So 1 becomes 0, 2 becomes 1, and 3 becomes 2. Now, of course, we don't do it manually, right? Never do this kind of thing manually, but we use something called recode. Recode is very important. Now, to do the recode, we go to transform. And this time, now we have 3 options actually. We code into same variable, we code into different variables, which means that you create a new variable to store the recode data. And automatic recode is something that more advanced, but I will go through them later. Now, for simplicity, now let's just do the recode into same variable. Now we want to recode the Q2. Okay, on the left-hand side, you see Q2. Here you see the variable name is inside the square brackets and the label is in front of it. Sometimes you may think that the label may be too long and you don't want to see the label here. And in that case, you can right-click here and choose display variable names. Then you will not see the labels. Now I want to do the Q2. So put the Q2 onto the right-hand side. Only Q2. Now, and then we go to the old and new values here. So this dialog is quite simple to understand. We input the old value and then we input the new value. So let's say we want to do change the 1, 2, 3 to 0, 1, 2. So if the old value is 1, then we want to change it to 0. So we put a 1 in the old value and 0 in the new value. Then we click the add button. So you see 1 and the arrow 0. So you can do the other two. If it is 2 here, you want to change it to 1. Add. And if it is 3 here, this one, and then you go change it to 2. So check the mapping here. 1 to 0, 2 to 1, and 3 to 2. Now make sure that this is correct. And then we click continue. Now, and then we click OK. So, and then you see the output viewer here. And in the output viewer, you see a lot of commands. It doesn't matter, but you can see the second last row. Basically, it says something like a recode, and then Q2, 1 equals 0 means it turns 1 into 0, 2 into 1, and 3 into 2. And execute. So go back to the data set and see all the data are now changed. We don't have 3 anymore. Now this is the way we recode. Recode means you convert the numbers to other things. The numbers are the code. Recode means we map the numbers to other numbers. And that is how we do it. So it is almost like a search and replace in Excel. But here in SPSS, we call it recode. Okay, so at this point, we have successfully cleaned the data. So that is the step that we have to do every time before we actually deal with the data analysis. No, 0 is not the same as missing value. Missing value means nothing. You don't know anything about it, but 0 is a value, right? So because sometimes you really have 0 as a valid value. So when it is missing, or if it is an invalid value, but you don't know what it should be, then you just make it missing value. And SPSS, when SPSS analyze that value, that variable, it will just skip all the missing values. So it will deal with it automatically, and don't worry about it too much. Yeah, this small dot here means missing value, and it will deal with it automatically. Okay, so let's say you can try this by yourself. You can click on any cell under Q2 here, and then let's do the very quick descriptive statistics analysis. And you see, it tells me now this time, because it is an ordinal level, so it knows that I should not do the mean. SPSS is quite, it still gets a mean here in the first table, but in the second table, it gives you the frequency distribution. You see missing 2. It knows that there are 2 missing values, right? So that is how it deals with things like this. It knows that there are 2 missing values. Okay, so at this point, I have finished what I want to do today. Now, to sum up a little bit, we have actually covered a lot of things today. I have talked about the concepts of statistics, including the definition of statistics, what we do here, descriptive statistics versus inferential statistics, the way of sampling. I gave you a few examples, and also the levels of measurement. I guide you through the SPSS user interface. I told you how to open and import Excel data, and how to use the data and variable editor. And finally, we gave a demonstration of how to do the data cleaning and pre-processing. Okay, so I think I should end this session here today. I have done video recording here. Okay, let me stop the video recording first. And I will